Assalamualaikum warahmatullahi wabarakatuh. My name is Mufti Putratama Sumarto. I'm from Electrical Engineering, and in this video I will explain about my project that is IoT based electrocardiogram. And then this video will contain what materials that it needed, and then how to make it, arrange it, the architecture design, and then the program, and then how it works, and how to obtain the data from the project. So with no more further ado, let's get started. Now I'm gonna tell you about what is electrocardiogram, and then I will tell you what is our aim in these projects are. So the first one, what is electrocardiogram? Electrocardiogram is basically a device that will record or determine the electric activity of our heart. It usually used to prevent or as an evidence of our previous heart attack. And then so the focus or the aim of this project is combining two technology. This electrocardiogram technology that is currently being widely used, and then microcontroller in here ESP32, which is have an application of wireless, and then it makes a possibility to upload the data that electrocardiogram has been determined to a cloud, or it can be accessible with IoT platform. So the aim is we record the electrical activity of our heart, and it send it to the IoT platform, so it will be can be monitored remotely. So basically your test is one place, and someone can control your electrical activity at another place. So this is the first aim. So what we are gonna search in this project is first how to what is the architecture design of this project, and then how to send the data to the IoT platform, and the last thing is how to gather the data. Okay, now I'm going to explain to you what is the tools that is needed for this project. First of all, this is a packet. This is a ACG sensor, like there. It is AD8232. This is a monitor, and if you can see, there are 5 different pins, and then one placement pad for this ACG electrode. There are basically 3 different electrodes, and have a connector that we place a replacement pad here. So this is the our sensor, and the next thing we have the microcontroller is SP32. This is have a feature of wireless, and then next thing is we have breadboard, and basically we have a MML jumper cable that will be used to connect it, connecting the ESP32 and the sensor. And the next thing is we have the cable, and then our power supply in this project is power bank, and then basically that's it. So we have sensor, the controller, the breadboard and jumper cable, and then power supply and data cable. Okay, now I'm gonna tell you the coding or the program of this project. First, we include Wi-Fi.h and PubSubClient.h for the library, and then next we define the Wi-Fi SSID and the password, because it will connect it to the Wi-Fi between ESP and the IoT platform, and then the token will be gathered at Ubidots or IoT platform. This is my utility name, and then we define the variable label, assign the variable label, and then device label, and then sensor A0. This is based on the IoT platform, and then we enter the auxiliary function as follows. First callback, char CPUI, P serial write and print in, and then this is basically we add a loop until it reconnected, so it will appears like a tamping MQTT connection. And then this is what happened if it fail connected, so it will waiting. We're trying to tell the consumer it can wait another 2 seconds. So this is the main function basically. We bring the Wi-Fi in if we begin pin mode sensor, and then serial print for Wi-Fi, and then if connected, if it continues to this one. This is basically the process of the loop. It creates the payload, and then it can add the variable label, and then it's the calculation float sensor equal to analog read by the sensor. And then this is basically the explanation of this is 4 is minimum weight, 2 is precision, which is float value is copied onto SRS sensor. Okay, so the last one is after the data has been gathered, it will send it to a platform or publishing the data to Audit's cloud. So after that, we're done, and it can be uploaded to the ESP32 for the data database. Okay, now, so here is the architecture of the project. First of all, we have a power supply that is connected to the ESP32, and the ESP32 is connected to breadboard that also connected to the HEG sensor. This is both connected by connecting 5 different pins. You can see here. First of all, GND, it will connect it to the GND part, the GND pin in this microcontroller, and then 3.3V. This one will connect it to the 3V3 pins, and then the output will connect to the VP, and then the LO min go to the pin number D22, and LO plus will go to D23. And then this SEG have a placement pair for the heart rate sensor. Here you go. So it is connected to a 3 electrode ECG electrode. They will be placed in 3 different parts of the body. There is a right arm, left arm, and then right leg. So the data is gathered in here, and we'll send it to here and form ECG graph, and from the ESP32 it can upload it to the IoT platform. Okay, so the IoT based electrocardiogram basically works by, first of all, the sensor ACG. So there's electrocardiogram three point. First, the red one is on the right arm, and then the yellow one is on the left arm, and then the green one is on the right leg, and it will connect to the sensor, and the sensor will send information to the microcontroller of the ESP32, and it will send by wireless connection Wi-Fi into the UbiDots or IoT platform. So you can see here, this is the result of the measurement. We get refresh. So basically it is the interval the data taken is about 1 second, so it change every 1 second, but the data is not really that soft as expected. Is because of some noise there is acquired during the obtaining of the data. So there is I think a little bit of noise that makes this result is a little bit of spiky.